Okay, welcome everyone to this session on Lifecourse. We've got three excellent papers, and I think in the interest of time, we'll jump right in. So the first paper is by Caterine Ramirez from Monmouth, and we will have all three presentations. They're all in video form, and then we'll have the discussants all at the end, and then we'll have time for questions. If you have questions from the audience, please feel free to use the Q&A to submit questions at any point. We'll do them all at the end. So we'll now see the video from Caterine Ramirez.
Hello, my name is Caterina Ramirez. I'm an assistant professor of economics at Monmouth University at the Department of Economics, Finance, and Real Estate. Today, I'm going to be presenting my paper on the effects of internal migration on adult fertility, evidence from the Mexican Life Survey. The research question of this paper is, what is the effect of internal migration on adult fertility? In particularly, I'm looking at the effects of childhood internal migration on outcomes of fertility on adult females using Mexico data. The motivation of this paper is that we know that migration is increasing, and both migration and fertility is going to cause shifts in the population distributions across space. So it will be interesting to understand particularly the relationship between them. Now, the relationship between them is going to have effects on the population size, the age distribution, and the characteristics of the labor force of a particular location. These factors will have implications for both individuals and societies. And they will affect both access to public as well as private services, because they will affect the composition of aging populations as well as working age populations, and hence they're going to affect aspects such as the old age dependency ratio or access to education. From the side of the individual, we can see other implications, in particular for females, as they make these trade-offs between having children or participating in the labor market. The data I use is the Mexican Family Life Survey, which is a longitudinal survey that interviews around 10,000 households during 3 rounds from 2002 to 2009. The sample I use is around 11,000 women, which are ages between 14 and 49, and those are the women that were asked the migration as well as the fertility module, and the ones that I have full data on their individual as well as household characteristics. Even though it is a longitudinal survey, for this paper, I structure my data set as a cross-sectional, but I did include time survey controls. Now, in terms of my variables, I use migration as a dichotomous variable that is 1, if the female changed locations, and a location is defined as a metropolitan area before the age of 12, but within Mexico. In terms of fertility, I look at different outcomes, including the total number of children, both at the intensive as well as the extensive margin. That is intensive, or the intensity of how many children the women had as adults, with 0 as a possibility. And the extensive margin is whether or not the female decided to have children, hence whether or not she's going to be a mother. Another outcome in terms of fertility I looked at, it's the age of the first pregnancy. For this research, I used regression analysis, and when I looked at the total number of children as my outcome variable, I assumed a Poisson distribution. This equation can illustrate this identification strategy, where F is going to stand for my outcome variable or the fertility variable, which could be the total number of children, the age of the first pregnancy, or whether or not the woman decided to have children. The parameter of interest, which is the parameter that I want to focus your attention on, is beta, and it stands for the coefficient next to the migration variable. The migration variable M is going to be 1 if the girl migrated before the age of 12 to a different metropolitan area, and 0 otherwise. I also include other control variables. In particular, I control for parent characteristics in order to address selection concerns. So the idea of this identification strategy is that there is going to be a time gap between the migration treatment and the fertility outcome. I also control for individual, parent, household, location, and survey characteristics to address the self-selection or other endogeneity concerns. What is really interesting about this paper is that I also looked at possible heterogeneous effects from different types of migration. Again, the parameter of interest is going to be beta, which is the coefficient next to my interaction term, which stands for migration times urban at birth times urban at time of survey. And the idea is that there could be different types of migrations, either from rural areas to another rural area, from rural to urban, urban to urban, or urban to rural area. Even though it is interesting to study the effects of adult migration on adult fertility outcomes, it is important to remember that this is a simultaneous decision. That is, females may be making the decision to migrate or to have children at the same time, regardless of the timing of the outcome. Using childhood migration gives us a time gap between the decisions, as well as an external agent making these migration decisions, which is the female's parents. So combining these results, namely the fact that there is a time gap, but also there is the parents that are taking these decisions, gives us our identification strategy. And as I mentioned, to address selection into migration, I include a variety of control variables, individual characteristics, parents' education, state phase effects, and types of migration. The results here, as you see, are highlighted on column 4, shows us that the parameter of interest is 0.05, and that tells us that there is an increase of around 5% on the total number of children an individual woman decides to have if she migrates. Now let's look at the coefficient on my interaction term. And I want to highlight the coefficient of minus 0.179, which tells us that if the girl migrated from a rural to an urban area before the age of 12, once she's an adult, she's going to have on average 18% less children than if she didn't migrate from her rural area. Combining these results tells us that if a girl moves from rural to urban areas, the total number of children she has as an adult is close to the number of children if she was born in an urban area. If we exclude women that migrated again as adults, we have similar qualitative results. The total number of children she has as an adult is close to the number of children she would have had if she was born in an urban area. I looked at possible mechanisms, namely the probability of marriage, the education level after migration, and possible migration as an adult. The same pattern repeated, migrating from rural to urban area leads girls to have outcomes similar to urban area females. The contribution of this paper is twofold. First, I found a strategy for causal identification. Even though there is previous research that looks at the causal effect of migration on fertility, these studies are at the household level or they look at male migrants. Some other studies look at very detailed administrative data, but they are in the context of developed countries or from international migrations to developed countries. So the combination of looking at individual females in a developing country context migrating from childhood as the identification strategy as a whole is a contribution of this paper. Second, this research tells us that migration, even during childhood, matters. Migration histories are important, and that on itself can have implications for research and policy. For example, if we disaggregate the ages at which children migrated, we might find that there is a critical age in which migration can have positive or negative effect on education, as some previous studies have found. This has implications not only on fertility, but on labor force participation and labor force outcomes, as education is closely related to human capital. This research is also relevant because of the importance of neighborhood effects at different ages, since preferences change during childhood. And I'm looking at changes of neighborhoods during childhood. The motivation for this paper is that there is increased migration, but there is also changes in the migratory patterns. So we need to start disaggregating the data and disaggregating the migratory patterns, including female migration, family migration, and children migration. My general objective was to add to the literature on the effects of migration on individual preferences, but specifically of female migration and female preferences to either have children or participate on the labor market. My results are robust to different specifications. In particular, when I use different probability distributions, they are still robust. I also look at other outcomes, as I mentioned, the extensive margin of motherhood. So whether or not a female decides to be a mother and the age of the first pregnancy. So in conclusion, my results show that the age of migration matters. Childhood migration from rural migration to urban migration is going to lead to fewer children and more mothers. Thank you.
Great. Thank you very much for that excellent presentation. And now we're going to move to Urvashi Jain from University of Southern California. Start the video.
Hi everyone, I will be presenting my paper, Early Life Exposure to Malaria Eradication and Later Life Cognition, Evidence from India. Malaria is an infectious disease prevalent in tropical and subtropical regions, and the parasite is transmitted to humans via mosquitoes. Children and pregnant women are especially vulnerable, and it can cause lasting damage due to neuropsychological deficits and general growth impairment. Thinking of the direct effects of malaria on cognition, if a fetus is exposed to malaria due to the mother, it can affect the anatomical development of its brain. Being exposed as a child can negatively affect the brain's functional development. And these damages to the formation of cognitive reserve in early life then show up as low scores on cognition tests taken as an adult. There are also indirect ways in which later life test scores could be affected by malaria. If it causes overall growth deficits, hampering the body's capacity to absorb nutrition, this can be studied using height, which is a good proxy for childhood nutrition. and there is substantial literature which has established a robust correlation between height and later life cognition. Similarly, early life insults can set one on the path of eventual cardiovascular disease, and a correlation has been found between cardiovascular diseases and cognitive decline. There is also research on the negative effect of malaria on children's education, possibly due to the school absences as children fall sick and due to reduced capacity to learn. Education is one of the most important factors which help in building a lifetime cognitive reserve. These can also lead to lower lifetime income, which then affects later life cognition. Historically, the burden of malaria has been high in India, and as per the most recent estimates, India accounted for 68% of malaria cases and 65% of malaria deaths in Southeast Asia. Hence, in this paper, I study the long-term effects of reduced exposure to malaria in early life on later life cognition. In order to get causal estimates, I use nationwide malaria control and eradication program. During the 1950s, the WHO sponsored malaria eradication campaigns throughout the world, which relied upon the then newly available insecticide DDT. These eradication campaigns were after the plausibly exogenous advent of DDT. Before the program, malaria prevalence in India was estimated to be 75 million cases in 1947, implying an annual incidence rate of 22%. The Indian government, along with support from the WHO, launched a malaria control program in 1953 in rural areas only. The program was renamed to be an eradication program in 1958 and covered the entire country by 1960. The efforts are reported to be initially successful. It was estimated that malaria had been eradicated from 88% of the target areas by 1964. But there were setbacks starting 1965 due to DDT shortages. There was the rise of urban malaria, and these led to resurgence by the mid-1970s. I use a difference in differences setup, comparing the change in outcomes between cohorts born before and after the eradication program in areas that benefit more against the same change for cohorts born in less malarious areas. I find that cohorts born after the eradication program in areas with pre-eradication malaria endemicity greater by 1 unit experienced gains of 0.3 standard deviation on an average in the cognitive domain of episodic memory for both men and women, and a similar result for verbal fluency for women. I don't find any positive and significant treatment effects on the measures of attention. I also don't find any effects on any of the indirect mechanisms, namely measures of health, education, or other economic outcomes. So we look at the effects of this program from the 1950s by using a difference in differences setup. In equation 1, YICD is the outcome of interest for individual I born in cohort C in geographic district D. A note about birth cohorts. A self-reported birth year is missing for 61% of the respondents. So for these individuals, I generate birth year as per the reported age. But since the data exhibits age heaping, I accordingly use 5-year birth cohorts. So I have 3 5-year birth cohorts in the pre-eradication group and 3 cohorts in the post-eradication group. Post captures exposure to the eradication program that is being born after the eradication period. So it's equal to 1 if the individual was born in or after 1960, and it's equal to 0 if they were born in or before 1952. I omit those born during 1953 to 1959 since I do not know the exact year in which the program was introduced in their district. Post is interacted with pre-eradication malaria endemicity, which is at the district level, and beta is the difference in difference estimator. So individuals born in erstwhile highly malarious areas are expected to experience greater improvements in cognition compared to the previous cohorts than those for whom the eradication program did not change much due to low levels of malaria to begin with. We had fixed effects for geographic districts and states and for both cohorts. Z includes basic covariates relevant in the Indian context, so dummies for scheduled caste, scheduled tribe, religion, and whether the individual's mother went to school. Standard errors are clustered at the district level, and as robustness checks, I also add district-specific time trends and birth year weather as further controls. And these district-level time trends control for the secular gains in health as well as resources. In equation 2, I estimate effects by cohort because it helps us understand whether the change actually happens right after the eradication program and for how long do treatment effects last. For individual level outcomes data, I use wave 1 of the study on global aging and adult health, abbreviated as SAGE, conducted by the WHO. SAGE Wave 1 was conducted in 6 countries in nationally representative samples. They collected data on health and well-being for older adults aged 50 years and above, and a smaller comparison sample of adults aged 18 to 49 years. SAGE Wave 1 in India was implemented in 6 states: Assam, Karnataka, Maharashtra, Rajasthan, Uttar Pradesh, and West Bengal. I used data on the health of individuals in rural areas born up to 15 years before and 15 years after the eradication efforts. SAGE does not ask individuals the district of birth, but asks whether they were living in the same region during their childhood. So I keep respondents who have been living in the same region in which they were born, which is 97% of the sample, and I use current district as a proxy for district of birth. About measures of cognition, I use the 10-word immediate and delayed word recall as a measure of episodic memory. Digit span forward and backward is a measure of attention and working memory, and respondent score is the longest number of sequential digits they could accurately remember. Verbal fluency is a task of naming as many animals as you can within a minute, and it's a measure of retrieving stored information. I use measures of pre-eradication malaria endemicity from Cutler's 2010 paper. They digitized a 1948 map indicating 6 possible malaria classifications, and using these, district-level measures of malaria endemicity are generated. And following their approach, I use a continuous index averaging all values within a district. Finally, I add data on weather and topography from the Indian Meteorological Department. Okay, now we get to the results. So here the dependent variables are z-scores of cognition measures. Columns 1 and 4 present beta from equation 1 for men and women respectively, and the subsequent columns further control for district-specific linear time trends and birth year weather variables. Among men, the difference in difference estimator is positive and statistically significant at the 10% level for both immediate and delayed word recall scores, with a robust relationship that persists even after the inclusion of additional controls in columns 2 and 3. And the magnitude of the effect is also large, with an approximate 0.3 standard deviation improvement in the cognitive domain of episodic memory for men. Among women, we don't see any effect on the immediate recall scores, but a positive and significant effect on the delayed recall scores, with the magnitude of the effect almost the same as that for men. We don't see any evidence for positive effects for cognition tests measuring attention or working memory, which is the digit span forward and digit span backward, neither for men nor for women. Looking at the test for fluency, we do see that women born after the eradication program in erstwhile highly malarious areas have higher scores on the animal naming task by 0.3 standard deviation, and no effect is found for men in this domain of cognition. Regarding the cohort effects, there is some evidence from the cohort analysis that the gains in cognition are largest for those born immediately after the eradication program. I don't find any significant effects of malaria on other variables which might be correlated with later life cognition, like height, hypertension, education, or other economic outcomes. As a robustness check, I use ecological factors as instruments for malaria prevalence, and the two-stage least square results are only robust for verbal fluency. Since the eradication program was only in rural areas, I also estimate the difference in difference equation for the same birth cohorts, but in urban areas, and none of these tests are significantly associated with malaria eradication, providing us with a further robustness check. A few things to consider about the estimates we saw. First, the program was essentially spraying DDT to kill mosquitoes, and there is research documenting the adverse effects of DDT on health. So these estimates are a combination of the gains in health due to reduced malaria risk, plus the possible harm to health due to DDT. Second, among the 2 malarial species prevalent in India, Plasmodium falciparum is more lethal than Plasmodium vivax, and I don't know the geographic distribution of these parasites during the study time period. So a reduction in malaria due to Plasmodium vivax could actually lead to the less healthy folks surviving, and this would show up as a reduction in the overall population health after the eradication program. Third, I used a 2008 classification of urban versus rural areas, and it's possible that with economic development, some previously rural areas are now urban, and I miss out on these in my analysis sample. Fourth, while the SAGE sample was drawn to be nationally representative, it covers only 6 states, and of these, 3 are high prevalence states. And finally, given the differences in child health, it's possible that parents might have adjusted their fertility or investments in children, and there is prior research on the effects of malaria eradication on fertility. But I'm unable to explore these as neither birth order nor the number of siblings are available in SAGE. So to conclude, I find that cohorts born after this malaria eradication program in previously more malarious areas experience gains in memory test scores, and these results overall suggest that even in the absence of improved schooling, which is possible in resource-constrained environments where returns to schooling are low, gains in cognition are still feasible by virtue of a less risky disease environment. This paper contributes to the literature on the early life origins of later life cognitive function, as well as the long-lasting effects of childhood exposure to malaria. The results are also consistent with previous findings from Mexico and Taiwan studying similar malaria eradication efforts. Malaria has not been eradicated from India, and it's actually becoming increasingly complex as mosquitoes develop insecticide resistance and parasites develop treatment resistance. Moreover, the proportion of older adults in India is projected to increase, and for whom cognition is a key health measure. And hence, any estimations of the burden of malaria should include these lifetime effects on cognitive capacity. Thank you.
Great. Thank you very much. Super interesting paper. I should clarify Urvashi's affiliation. She got her PhD at University of Southern California and is now a faculty member at University of South Alabama. Is that correct?
Yes, thanks, David.
Okay. Okay, our third and final paper is by Rocco Zizamia, formerly of University of Cape Town, now at University of Oxford. Rocco, take it away. Well, actually, Paul, take it away with Rocco's video.
Hello, my name is Rocco Zizamia, and I'm presenting work with Vimal Ranchard that we've done measuring earnings inequality over the Lifecourse using South African data. The motivation for this research comes out of one negative feature of inequality as standardly measured, which has to do with the fact that inequality conventionally measured uses cross-sectional data. That is, it measures inequality at a point in time. However, inequality between person inequality is perhaps more meaningfully reflected by inequality in the cumulative distribution of resources over time. That is, it's not just the differences between people, between the earnings of people at one point in time, but how those earnings evolve over time. So the question is, why isn't inequality more often measured in this dynamic way? The answer to that is that it's extremely demanding in terms of data. What we need is long-term panel data, preferably over the Lifecourse. And while this is available in some developed countries, in developing countries, this is not available. So what we do is we use South African genuine panel data spanning 9 years to construct a synthetic lifetime panel. And then using the synthetic lifetime panel, we compare cross-sectional earnings inequality to inequality in medium-term earnings, which we compute using the genuine panel over 9 years, and then lifetime's earnings inequality, which we compute using our new lifetime panel. So to crystallize some of the issues underlying the dynamic versus static measurement of inequality, I'm going to outline two stylized cases. The first case comprises two agents in an economy with 3 time periods. In the first time period, Jill has entered the labor market, but Jack has not yet. By the second time period, Jill's got a promotion, she's earning more, and Jack has just entered the labor market. By the third time period, Jill's left the labor market, and Jack has now got that promotion that Jill had previously got. Measured at t+1, we observe substantial inequality in this economy, but measured over time, we observe no inequality in this economy. So this is the case of a positive age earnings relationship in which over time, people's earnings tend to grow on average. We observe this in most real economies. The second case also occurs over time, but changes the direction of inequality measured over time in a different, changes that inequality measured over time in a different direction relative to case 1. That is, in this stylized scenario, low-income earners are more likely to experience periods of unemployment than high-income earners. So over time, inequality, which is measured at one point in time, is compounded relative to inequality. Inequality which is measured over time is compounded relative to inequality which is measured at a single point in time. These two processes co-occur in reality, and which process dominates in determining the difference between inequality measured over the life course versus inequality measured at a cross-section is an empirical question. So this is just to show that in South Africa, we observe this positive age earnings relationship. This is inclusive of periods of unemployment. Sorry, this is exclusive of periods of unemployment. This is inclusive of periods of unemployment. So there's a bit of a moderation of that trend in later years. That's this case 1 scenario. We also observe, using South African data, that the case 2 scenario is borne out. So that is, so here we use the NIDS balanced panel. So in NIDS, we observe the same individual over 9 years at 5 different periods. So we can observe whether they were employed at 1 out of 5 periods, 2 out of 5 periods, etc. And what we see is that the mean earnings for those who are employed infrequently when they were employed are much lower than the mean earnings for those who are consistently employed when they were employed. So in other words, and the difference here is those people who are employed only 1 out of 5 periods were earning only 1/3 of those who are employed in 5 out of 5 periods in the periods that they were employed. So this dynamic might be inequality enhancing over time. So to investigate this, we create a synthetic lifetime panel so that we can compute lifetime earnings inequality. Since we don't observe individuals over their lifetime, but we only observe them over 9 years in the NIDS data, we have to create a panel of synthetic individuals who have valid observations from the age of labor market entry to the age of labor market exit. I'm not going to get into the nuts and bolts of how we do this, but I'm just going to give intuition, and you can refer to my paper, or we can discuss it in the question and answers if you'd like more information. The intuition here is that we link young individuals in the youngest cohort of adults, so those between 18 and 21. We link them to relevantly similar older individuals using a matching procedure, so as to form a chain of observations across the life course. Once we've created the synthetic chain of observations, we can compute intertemporal inequality. So this table just compares characteristics for those who are in the balanced panel, this is the genuine panel, versus those in the synthetic lifetime panel. You'll see that they're generally balanced, except for characteristics which either vary over the life course, or which display secular trends. So for instance, in the balanced panel, we see that young people have higher education than old people. Those at 54 have lower levels of completed secondary education than those who are 27. Because of the features of the matching algorithm, we match with replacement. Younger cohorts are matched with older cohorts who have higher levels of education. So there isn't balance in education or in employment, which you see here, where there's a hump in terms of employment rates over the life course, which we can see over here. Because the matching algorithm isn't able to flexibly account for that, what we see is that employment rates, as they grow, they remain persistently high. This is just a feature of the data that we need to bear in mind. So the main results are that the Gini coefficient, so what we look at in the red column here, we compute the Gini coefficient and the 9:10 ratio, which I'll leave out. We compute the Gini coefficient for those first, only on those who have positive earnings, and then we include those who have 0 earnings. That is, it accounts for the non-employed. What we see is that earnings inequality is expectedly very high in South Africa. If we compare this to pooled earnings in the NIDS genuine panel over 2, 3, 4, or 5 waves, what we see is that when we're measuring earnings inequality conditional on earnings being above 0, that is excluding those who are unemployed in every period, every of 2, 3, 4, 5 periods, we see that earnings inequality increases. And what's doing that, what's accounting for this increase, is that case 2 dynamic that I described above. That is, inequality in employment dynamics is driving up this earnings inequality as measured over the medium term. Because over the medium term, aging dynamics are less, have less bite. When we look at our synthetic panel results, however, we see a sharp decrease in inequality relative to both the cross-section as well as the genuine panel, which is over the medium term. And what we propose as the explanation to this is that over the long term, these aging dynamics are dominating the employment dynamics as a determinant of, as driving this inequality downwards. So what we seem to be able to see quite clearly here is that over the medium term, inequality in employment dynamics seems to be driving inequality up, whereas over the longer term, of the lifetime, earnings, this positive age earnings relationship seems to be driving inequality downwards. So I'm just going to, we can come back to this, but these results appear to be robust to whether we use different inequality indices, whether we use different matching strategy to create the synthetic panel. And there is also some concern that a matching process might mechanically bias lifetime earnings inequality downward. And we believe that we're able to write that off as a possibility with some confidence. However, there are some major issues remaining which make us cautious about interpreting our results with too much confidence. I'm going to leave these up here without discussing them in detail, and we can discuss them in the question and answer session. But in brief, there's some concern about the representativeness of the sample, and a deeper issue about what exactly the population is on which we're making inferences. Since it's a composite population which pools or which links different cohorts together, it's unclear what the synthetic panel, what population the synthetic panel refers to in reality, because it's a composite of these different cohorts. The second issue here is that it's difficult to understand how secular change is going to affect results. That is, for instance, major events like the rapid expansion of education or transition out of apartheid in South Africa. How that affects inequality as measured over the long term in the synthetic panel is unclear. And then there's some concern that measurement error might bias medium-term inequality upwards, inequality in earnings upwards, leading us to overestimate the inequality increasing effects of employment dynamics. I'm happy to get into any of these and would greatly appreciate your comments as well. To conclude, lifetime earnings inequality in South Africa appears to be lower than a point-in-time estimate. The most likely explanation is the effect of aging dynamics. Employment dynamics increase inequality in the short to medium term relative to a point-in-time estimate, but we have reason to be cautious in our interpretation of these results. Thank you very much for your attention. I'm looking forward to your questions and to seeing everybody else's presentations. Thanks for joining me.
Okay, thank you, Rocco. Thanks to everybody for very well prepared presentations. We'll now move on to comments. So we will now go to Rocco live, who will discuss the paper by Catarina Ramirez.
Hi everyone, and thank you. I enjoyed both the presentations, and Catarina, it was a it was a pleasure to read your paper and yeah, to get into the details. So yeah, it was a great pleasure to read it. It's motivated extremely clearly, both from a theoretical and from a policy perspective. Your question is really clear and you answer it precisely. It exploits, I think your paper cleverly exploits a simple but a very neat feature of the Mexican family life survey, and that's the fact that women of childbearing ages, we observe women of childbearing ages, for women of childbearing ages, we also retrospectively observe migration dynamics that occurred during childhood. So this allows you to neatly separate out fertility outcomes from self-selection into migration, which is sort of the big confounding factor usually. So yeah, the question that you answer is, what is the causal effect of childhood migration on fertility outcomes? And I think of particular value is your ability to identify how the answer to this question differs for urban to rural migrants, or rural to urban migrants, or as you also said, urban to urban or rural to rural migrants. And I think that's of particular interest. You also acknowledge in the paper, though, that these results only hold for childhood migration in the narrowest sense, rather than for migration more generally and its effects on fertility. Your discussion, though, of mechanisms in the paper, the mechanisms underlying the causality which you identify does go some way in helping us to understand how the effects of migration might impact fertility more generally. So, for instance, you speak about there's a location component to this to the causal channel that you identify, which is fixed, whether someone migrates in adulthood or in childhood. However, there's also a preference component which affects children more intensely, since they sort of have more time to update their preferences in the new urban or rural environment. But I don't see how one could straightforwardly quantify the relative contribution of these sort of two components, the location component versus the preference component. And if one could quantify the contribution of the location component, then one could sort of go some of the way in answering the sort of question of mechanisms underlying the relationship between migration and fertility more generally, not just in the child case. So the other thing that differentiates adult from child migration, as you point out, is that for adult migration, there's self-selection into migration, which is endogenous to fertility outcomes. And to me, this seems like the fundamental problem here, right? And so it's not a problem with your paper. It's a problem in the sense that our tools in economics aren't well equipped to illuminating multi-causal phenomena like fertility in the case of adult migration. So anyway, in summing up, I think your paper answers the question that it sets out to answer exceptionally well and precisely. But going beyond this, I'd like to hear from you what, if anything, we can learn about migration and fertility more generally. For instance, can we get a sense of whether adult self-selection into migration and fertility outcomes work in the same direction as preference and location outcomes? And can we say something about the relative importance of location and preference components in your paper? Yeah, that's it from me. Thanks so much. I really enjoyed it.
Great. Thanks, Rocco. Good timing. Okay, trying to remember the algorithm here. Okay, so next we have Katarina discussing Urvashi's paper.
Would I be able to share my screen?
Yes.
Okay, I think I can, yeah.
You should select the file itself normally, but that's okay. Can
Yeah,
you
go
make that
ahead.
larger?
Oh,
It's okay.
It's fine.
is that better?
It's okay, go ahead.
Yes, thank you very much for letting me read your paper. It was very interesting and also related to my interest of research because of these relationships on health and outcomes later in life. This paper, in summary, the title says it all, which I usually really like when the title is very specific. It talks about how malaria and a program of eradicating malaria is going to have an effect later in life. So it analyzes the effect of this program that eradicates malaria in India, and it finds improvement in memory through 3 different outcomes, and it looks at 3 different variables on memory. I'll try to be brief. So 2 ideas or a couple of ideas about stress and a couple of ideas in terms of feedback. I think this paper gives like a huge contribution when we think about health improvements throughout the life course, because it's especially in developing countries, it's very difficult to analyze things that happen earlier in life, even though we know that childhood investment and childhood improvements and childhood outcomes are really important. It's very difficult in developing countries to find this relationship between what happened to communities or adults in childhood and what we see once they're adults. So this data set or this paper is very creative in the way that they look at the timing of this malaria program, which, as the author explained, is very pervasive in India. So it's going to be very relevant in terms of policy. So what happens if we want to actually improve treatment of malaria, and what is going to happen throughout the life course of an adult? The paper is well explained. It talks about the relevance. I agree, it's a very big contribution when we're trying to disentangle interventions in childhood or earlier in life to outcomes later in life. And it addresses many data challenges, like, for example, there's not a lot of availability in terms of birth year, or there's heaping. So then the authors used cohorts. It also looks at data of aging. It deals with issues of like, how do we actually define location or potential issues of migration. So it does different robustness checks in rural versus urban areas. It also does different specifications. In particular, I like the disentangling of gender, and not only they do the disentangling of gender, but she also explains why it's important to look at different genders. And it doesn't look at just one outcome variable, it looks at different outcome variables to see what is the effect of on cognitive from this like malaria prevention program. Now, the feedback I would like to have to the authors, one is in terms of the identification strategy, and the other one is in terms of relevance for policy, particularly when they discuss the mechanisms. So in terms of the identification strategy, the authors write that there is this strong correlation between weather and health, and they later use this like weather as an IV for malaria. But they also state that there is a correlation between malaria and weather. So she includes all these like controls about weather. So that in itself raises some doubts about the exogeneity, about the exclusion restriction of the IV on weather. So I'm not sure if it was like the clarity of whether weather was used or not in the controls, or if the discussion on weather was because it was going to be later used in the IV. So that is something to take into account. Like, are we using weather as an IV, or are we using these like weather characteristics as control variables for malaria and later in life outcomes? The other issue that I thought would be worth thinking is, and I quote, "There's gains in cognition are usually largest for cohorts born right after the eradication efforts concluded." So it raises the question of perhaps there were other programs happening at the same time in those areas that also suffered a lot from malaria. So maybe giving a little bit more background about those particular areas, or like a couple of footnote discussions, would clarify like this concern. And in terms of the other feedback is, it would be really nice if some of these the relevance for policy, if some of these like numbers are translated into, okay, how do I use this 0.3 improvement in standard deviation? So should I translate this as, yes, education is fine, keep investment on education, but also think about eradicating malaria, or it's very important, so we should invest even more in trying to help eradicating other tropical diseases. And I think in the presentation, the authors did discuss this, like even in areas that there's not a huge education infrastructure, there's still improvements in cognitive ability from this malaria program. But it would be nice to have it like clearly stated in the paper. But yeah, very big contribution to like to look at age later in life improvements from earlier in life programs. So thank you very much.
Great. Thank you for those comments. And finally, we'll have Urvashi commenting on Rocco's paper.
All right, thank you everyone. Fantastic discussion so far. So about Rocco's paper, this paper estimates measures of lifetime inequality in South Africa, and they managed to do so despite the lack of long-term panel data by constructing a synthetic panel. And the main finding overall is that lifetime inequality is lower than cross-sectional. What I liked is that the paper has a very ingenious approach to getting at these measures of lifetime inequality in a developing country setup. And as they mentioned, most of these countries do not have the kind of longitudinal data that is needed for such an exercise. So again, a big contribution. And I also like the way they explained how they constructed the panel and the robustness checks, especially the ones where the authors provided an upper and lower bound for their estimates with the different matching strategies. I thought that was very convincing. In terms of improvements or extensions, I think first of all, this is, I'm just about presenting this a little bit better. It would be helpful to add the percentage by which lifetime inequality is lower than cross-sectional when discussing the findings. I mean, of course, the readers can calculate this on its own, but it's just really good to add, especially in an abstract, because right now it all seems qualitative, and it would be nice to add some quantitative aspect to it. And my second main comment is, given the context, which is South Africa, much of this inequality would be racial, right? So can the authors add some insights regarding this? So, for example, is the difference, let's say, between cross-sectional versus lifetime greater or smaller for Black versus white population or something like that? Because I think that would really enhance the contribution of this paper. As you rightly mentioned, that South Africa has the highest inequality in the world, but to be able to add on a sort of a race analysis to it, I think would be really, really helpful. And just lastly, this is, just a comment. Like I know that, data availability is a concern, but there is one other developing country, which is Indonesia, which has panel data spanning 21 years in case the authors might be interested in doing something similar, because right now you're dealing with less than 10 years. But in case you were ever interested in sort of expanding your work, I think the Indonesia Family Life Survey would be very, very helpful. Thank you.
Great, thanks a lot. Before we have the authors respond, maybe I'll open the floor to questions from the audience. We've had a couple, some which have already been answered. But let me call on Murray Lebrant, who asked a couple of questions for Urvashi. And Murray, maybe. Yeah.
Yep.
You got the floor. Yeah, go for it.
Well, simple questions. The one was just, in the formal modeling of the link between of cognition. There's really a model in the middle of the paper on the malaria and the cognition of a long run model of cognitive development in a sense. I guess that's how I was thinking about it. And so I was just thinking that the model, the actual covariates that are included, obviously you've got to use what you've got, but the paper would be strengthened, in my opinion, if one could show that what you've got also corresponds to the type of covariates that you need in a model of cognitive development, if you like, so that the malaria intervention has a bit more bite as as a determinant in such a model. I guess that was my substantive point. The other point was really just about the fact that there is this, there's this tradition now with the early RCTs of following up to look at these long run impacts, as this paper does. And so the famous example is the deworming studies, which are now almost looking at the retirement behavior of people who were dewormed. But there's also the famous BedNet study, which was really a malaria study. So I was just wondering about the possibilities there. Thank you.
Okay, we'll get to responses in a moment. If anybody else wants to ask a question from the audience, feel free to raise your hand or enter it in the Q&A. I just had a follow-up on the comment that Katerina made about sort of measuring, for example, how big is a 0.3 of a standard deviation increase in cognition? We have, as you may know, at University of Michigan, we have the health and retirement study. We do a lot of work on cognition, and an interesting metric that's often used, for example, we've had a bunch of research about the impact of education on cognition, and a very natural measure is to sort of translate it into the number of years, because sadly, of course, we find in the HRS that as people get older, their cognition declines, and it actually makes kind of a nice measure. So, for example, the difference between having high school and college education is equivalent to something like 10 years of cognitive decline. Well, the other way around, but in sort of the U.S. sample. So just kind of an interesting kind of metric of how much cognitive decline do we see between age 70 and 80? You'd probably have to use something like the HRS, although there are measures also in India now. Not sure how far along those are. We don't see it longitudinally in the same way we do in the HRS. Anyway, just an idea. So I don't see other hands coming out. Let me open it up to I'll go in the order of the papers, which is Katerina. Have I got that right? I'm already losing track of, yes, Katerina was the first presentation. Any comments you have, or if you want to raise any other questions for the other papers, go ahead, floor is yours.
Oh, thank you. Well, I was just gonna say that one of the points that Rocco mentioned were very, very on point, because one of the main things is just how do we identify like adult migration, this decision of that will be like very interesting, very useful, but just think the way other studies have used it is precisely looking at like either household data or migration data. So if you think about one female, I'm going to migrate to the suburbs because I want to have children. I may move before I have children. So it's very difficult to identify this effect. Is it migration that caused the children, or is it I wanted to have more children and then I moved? So from a individual female perspective, that would be very difficult, which is why, okay, let's exploit childhood migration. But as I said, there's other studies that look at like household data, or they look at like international migration, and there's some strategies using like price of oil to look at international migration. So that has some value, and it wouldn't, and there's also a lot of literature like in demography journals that they don't exactly identify causality, but they give these trends. Is it assimilation? Is it preferences? Is it labor market? So it's not causality, but it still gives a lot of information. Now, in addition to, I think it's interesting that it's childhood migration, you also were very on point when you talked about it would be very cool if we can disentangle, is it about location or is it about preferences? And one way to do that is looking at like panel data and look at family data. And if we have information of siblings, then I could disentangle that if some migrated and some didn't. There is a little bit of information about families in the data set that I have. There's not enough variation, but I'm exploring that to see if I can disentangle, is it the location or is it the preferences? And there is some other studies in like the United States that look at the neighborhood effects and later in life, like teenage pregnancy, that kind of looks at that. But the bottom line is location matters and is going to affect individual preferences. And this is a step forward into, okay, women's individual preferences will change and women are the ones that are having the baby. So maybe we should start looking at a childhood migration for females and disentangling that data. And actually, since I have the floor, I also wanted to say to Rocco that I really like the paper, and I was thinking one possible application of this model of inequality would be also like females and comparing either entering the labor force later in life or an interruption because of having children. So you could apply your model to those like cases. So how is inequality going to change that? I had a children earlier, so I had to delay my going to education, labor force, etc. Or I had a children and then I had to interrupt. Like which one has like a worse effect or something like that? Thank you.
Very good. Thank you. Urvashi.
Sure. So thank you everyone for the comments. So I'm gonna actually start with Marie's comments. Again, super helpful. And I think I agree that sort of focusing on what is it that contributes to long-term development of cognition would really enhance the paper's contribution, especially in the context because more than 50% of the sample has never had any formal education. So what is it that's shaping these people's cognition? And that's exactly where I'm trying to sort of make a case for my paper. So thank you very, very much. And then again, Katerine's comments, very, very helpful. So about the IV, I agree that, theoretically, one might worry about exclusion restrictions. So what I do is in the OLS, I only add birth year precipitation and birth year temperature as controls. But when I'm doing the IV, I don't use those, but I instead use a historical average of precipitation, temperature, altitude, and humidity, and the squared values, and a combination of these as the IV. So that's the difference between the OLS and the IV. And this approach has been sort of standard in this literature on malaria, where there's a lot of measurement error about, measures of malaria from like going back to the 1940s. But yeah, I think I need to think a little bit more about the exclusion restriction, because on the one hand, I am using these aspects in my OLS, and then I'm also using them in my IV. About your comments on cohorts. So in terms of the other stuff that might be going on during those years, I think the biggest thing that happened next was the Green Revolution in India. And that would have sort of started, it took off in a couple of districts in the early 70s, and that's when it took off after that. And my analysis ends in 1975. So, but I definitely need to mention that explicitly in the paper. Like I had it in my head, but it's not really mentioned in the paper right now. So I think it needs to be in there.
But can I just jump in on one related point?
Sure.
That the one of the things that often happened in these areas that went along with malaria eradication was, at least there's a famous example in Nepal, where sort of massive agricultural expansion went on in the same area, where some malaria was eradicated,
right,
and big plants. So you might have had, this would be sort of pre-Green Revolution, but there might have still been like, increased food and nutrition and so on, that obviously would be a potential confounder.
Right. No, that's a good point. I I don't have, I mean, I think there's some data on yields in India. I think I might be able to use that, because you're absolutely right. I think a big part of why the Indian government wanted to deal with this was because malaria was essentially like, really, really bad for agricultural productivity, because the farmers would fall sick and not really go and work in the farms. So yeah, I think that's a good point, and I need to think a little bit more about this. Having said that, I think some of this would be captured by the district time trends, because what's happening here is, over time these districts are becoming better, and that was my intention, trying to capture whatever changes that happen in income or resources at the district level. But I could definitely try and add this a little bit more explicitly. So thank you, David. So yeah, Catherine's third point was about policy. And again, I think that's very, very useful. I have thought more about what to make really of this 0.3 standard deviation. Like what might it mean to policymakers, right? And it turns out I don't have any clear answers yet, because for example, there's some literature on dementia which says that, let's say you're classified as, mild cognitive impairment, or, as dementia if you fall, let's say, in the lower tail of the population. But again, that research seems to vary a lot depending on the context. So you're right. I need to think a little bit more about what exactly does this 0.3 standard deviation mean, and how can policymakers use it. So thank you.
Well, just to expand on the comment I was making, I mean, within SAGE, I mean, they're doing this measure on lots of people. So you could look even within SAGE at some other comparison that has that kind of standard deviation, age being one obvious one, but perhaps some other, or maybe education or something. So if you could say, like, this is equivalent to, as I suggested, 10 years of cognitive difference between 80-year-olds and 70-year-olds, or something like that. You wouldn't have to go outside the SAGE data.
Right.
Okay, great, thanks. Rocco.
Great, thank you, Katerina and Urvashi, but also David, actually, from a previous seminar where you saw this work presented, and your comment really helped in some of the robustness stuff tests. I mean, Urvashi, your comments are really good, and yeah, I think things to integrate for sure. About the Indonesia panel, it's worth having a look at. I mean, I was even playing around with Caterina's Mexican family life survey earlier today, and looks good as well. And it's got 3 periods of panel data, which would allow one to use this sort of approach. Perhaps I'll just use the opportunity to make 2 comments, which are both sort of caveats, actually. The first is things that I'm trying to think about. The first, well, there are 2 issues here. The whole exercise hinges crucially on the matching strategy. Like if we can, the validity of the synthetic panel depends on whether we're able to match younger cohorts with relevantly similar older cohorts. So essentially what you're doing is creating an unbroken chain of observations from those who are aged 18 at a particular point in time to those aged 60 at the same point in time. So you've got to assume, you've got to have some stability assumptions to enable you to say that in 45 years, the 20-year-old is going to be, or in 30 years, the 20-year-old is going to be on the same economic trajectory as the 50-year-old that you match that 20-year-old to. So that's the sort of big, like data manipulation challenge. But even if we get that right, and I think, David, for instance, your previous comment that you made helps us in our confidence of the matching strategy. Even if we get that right, the bigger question is, what is the population on which we're doing inferences? Like, what is this composite population of 18-year-olds and 16-year-olds measured at the same point in time? It's not, I mean, in the most straightforward, or in the most like pragmatic way, it's like, if a survey is released with weights, with population weights, how do you use those population weights with this with the synthetic panel, which to answer that question, you have to understand what the population on which you're doing inferences is, and that's not clear. That's not straightforwardly clear to me. So those are the two sort of major caveats. At the same time, I think sort of accepting it in its, in all of its roughness, the value, hopefully there is still value in what at the end of the day is a first estimate of lifetime inequality in a country like South Africa. So yeah, thanks. That wasn't really an answer to any question. That I was being a bit indulgent, but yeah, thank you.
Great. Aaliyah is our moderator. Aaliyah, did you have any comments? Our Q&A moderator.
Oh, hi, David, and hi, everybody. Really very, very, very interesting papers. So I did more of the listening, and I think the discussions from the presenters of each other's papers brought out the key issues there. So really not much, David, for me to say. I had a question. Actually, I was wondering whether if you are a speaker, you can't type in a question because you can only respond, it looks like. But Katrina, I think you studied on migration. I did a paper once. I using more limited data than this, but looking at different migration patterns and how these affect child survival in sub-Saharan Africa. So the issue about looking at both rural, urban, and urban to rural migration, as well as rural to rural or urban to urban, as different sort of migration dynamics. I was just curious. I might have missed this when you were doing the presentation. The reverse migration route from urban to rural area. Did you say you looked at that as well, in terms of what impact it had on fertility?
Wait, so if I look at urban to rural, rural to urban, yes, I did look to rural to urban.
Rural, sorry, urban to rural. Yeah, rural to urban is what you emphasized.
Yeah, so rural to urban, generally speaking, the patterns that I see is that if wherever you move, they call the assimilation trend in demography. So wherever you move, you assimilate to whatever happens there. So when you move through urban to rural, you're going to have slightly more children than if you just stayed in the urban area. But since I did different robustness checks and different specifications, sometimes it was significant at like the 10% level. So it wouldn't change as much, but the number indicates that the number of children you're going to have is going to be closer to if you were just born in a rural area. So I did look at all of those different specifications.
All right,
and
okay.
I had to, when you do this like number of children, you have to make an assumption of what probability distribution it is. So I did different probability distributions, and sometimes it was significant, sometimes it wasn't. So I'm not confident in that result.
All right, okay, great.
Okay, great. Well, we should declare the session closed. We have a Meet the Authors session coming up on a different Zoom channel. It's just a regular Zoom room, so I encourage the authors to go there. I'm going to jump over there because I've actually got a couple more questions for Katarina and maybe others.